Hello, in this lecture we'll answer on two questions. The first question, we'll find out the blue area, and in the second question we'll find out the radius of this circle that blocks triangle ABC. So we'll start with the first question. In the drawing we have this circle, and we know that the diameter of this circle is AB, and the radius of this circle equals to 13 units, and inside this circle we have triangle ABC. Triangle ABC is inscribed by the big circle, and inside the triangle ABC we have a small circle. So the small circle is inscribed by triangle ABC, and the radius of the small triangle equals to 4 units, while the radius of the big circle equals to 13 units. And we also know that AB is the diameter of the big circle, and we want to find out the blue area. Okay, so we'll define the center of the small circle as O. We'll define the point of tendency of tangent CB with this small circle as M. We'll define the point of tendency of tangent AC with this small circle as N. And we'll define the point of tendency of tangent AB with this small circle as L. In the next step, we'll join points O and M together by a straight line. O is the center of the small circle. M is a point on the small circle itself. So actually this is exactly the definition of a radius. So OM equals to the radius of this circle. We define the radius of this circle as small r, and small r equals to 4 units, according to what is given as the question. And we also have rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here the radius OM, it is drawn to the point of tendency, that is to say, it is drawn to point M, that is the point of tendency of tangent CB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. In the next step, we'll join points O and N together by a straight line. O is the center of the small circle. N is a point on the small circle itself. That is to say, ON is the radius of the small circle that is equal to 4 units. And here we have the radius ON that is drawn to the point of tendency, that is to say, it is drawn to point N, that is the point of tendency of tangent AC with this small circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to the radius NO. So AC is perpendicular to NO, according to rule number 1. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. And we also have another rule, rule number 2, that says that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So here, peripheral angle ACB, this angle ACB rests on AB, that is the diameter of the circle. Therefore, peripheral angle ACB will be equal to 90 degrees according to rule number 2. So this angle equals to 90 degrees. So actually, the quadrilateral ONCM, we have 1, 2, 3 right angles. Okay, so I write it down. In quadrilateral ONCM, we have 1, 2, 3 right angles. The sum of right angles is 90 times 3, 270 degrees, plus the size of the fourth angle, that is actually angle MON, this angle. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So we subtract 270 degrees from this equation, and we get that the missing angle MON, equals to 360 degrees minus 270 degrees, it is 90 degrees. So the missing angle MON is a right angle, and this angle equals to 90 degrees. So actually, quadrilateral MONC is 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral NOCM as a rectangle because it has 4 right angles. Quadrilateral ONCM is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of a rectangle NOCM, they are equal to each other. That is to say, NO equals to CM. NO equals to CM. Okay. But NO equals to 4 units. According to what we have already found out, NO equals to 4 units. It is the radius of the circle. So from this equation, 4 equals to NO equals to CM, we will derive that CM is also equals to 4 units. Okay, CM equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we will conclude that OM equals to NC. OM equals to NC. Repeat again. OM equals to NC according to the rule that the opposite sides of a rectangle are equal to each other. But OM equals to 4 units. We already found out that OM equals to 4 units. This is the radius of the circle, the small circle. And from this equation, 4 equals to OM equals to NC. We will derive that NC is also equals to 4 units. NC equals to 4 units. So here, NC equals to 4 units. So actually, we found out that quadrilateral NCOM, it is not a rectangle but a square, because all of its sides are equal to each other. Okay, so in the next step, we will define side AC of triangle ABC as A. AC equals to A according to our definition. We will define side BC as B. BC equals to B according to our definition, and we will define side AB of triangle ABC as C. Okay, so AN equals to A, CB equals to B, and AB equals to C. According to our definition. So what is the length of line segment AN? For the drawing, it is very easy to see that the length of line segment AN, here AN equals to AC minus NC. AC minus NC, AC minus NC equals to AN. Okay, AN equals to AC minus NC. So actually AN equals to AC equals to A according to our definition, and NC equals to 4 units according to what we have already found out. So in conclusion, we found out that AN equals to A minus 4. AN equals to A minus 4, so we can write here that AN equals to A minus 4. Likewise, we will find out the length of line segment MB. Here, MB, the drawing, it is very easy to see that the length of line segment MB equals to CB minus CM. CB minus CM equals to MB. So MB equals to CB, that is equal to B according to our definition, minus CM actually, minus CM, that is 4 units according to what we have already found out. So in conclusion, we found out that MB equals to B minus 4. MB equals to B minus 4. In the next step, I will present to you rule number 3. According to rule number 3, the lengths of two tangents from a common XR point to a circle are equal. I repeat again, the lengths of two tangents from a common XR point to a circle are equal. So we'll focus on the common XR point A. From the common XR point A, we have two tangents to this circle, tangent AL and tangent AN. And according to rule number 2, they are equal to each other. Tangent AL equals to tangent AN according to rule number 2, as I mentioned. But we have already found out that AN equals to A minus 4. Here AN equals to A minus 4. So we can write here that AN equals to A minus 4. And from this equation, AL equals to AN equals to A minus 4, we will derive that AL is also equals to A minus 4. AN equals to A minus 4. Here AN equals to A minus 4. In the next step, we'll focus on the common external point B. So we'll focus on the common external point B. From the common external point B, we have two tangents to this circle, tangent BL and tangent BM. And according to rule number 3, they are equal to each other. That is to say, BL equals to BM according to rule number 3, that the lengths of two tangents from a common external point to a circle are equal. So BL equals to BM. But here BM equals to B minus 4. We have already found out that BM equals to B minus 4. We have already found out that BM equals to B minus 4. And from this equation, BL equals to BM equals to B minus 4. We derive that BL is also equals to B minus 4. BL equals to B minus 4. Here, BL equals to B minus 4. So in conclusion, we found out that BL equals to B minus 4 and the AL equals to A minus 4. It is given us the question that AB is the diameter of the circle, and any diameter, it is twice as long as the radius. So the diameter AB of this circle, it is twice as long as the radius. So if the radius of this circle equals to capital R, then the diameter will be equal to 2 times capital R. And it is given us the question that capital R, the radius of the big circle, equals to 13 units. So 2 times 13 is 26. That is to say, the diameter of the circle AB equals to 26 units. So we can write here that C, that is the diameter of the circle, equals to 26 units. Okay, so here the diameter AB of this circle equals to AL plus LB. AL plus LB. I'll repeat again, the diameter of the circle that is AB equals to AL plus LB, that is to say AB equals to AL is A minus 4, plus LB is V minus 4. So in conclusion, we found out that the diameter of the circle AB equals to A minus 4 plus B minus 4. That is to say the diameter AB equals to A plus B minus 4 plus minus 4 is minus 8. So the diameter AB equals to A plus 3, A plus B minus 8. Here we will add to this equation 8, and we get that. But first of all, we know that the diameter AB equals to 26 units. Now we will add 8 to this equation, and we get that 26 plus 8 is 34, equals to A plus B. Found out that according to equation number 1, A plus B equals to 34. Here we will square this equation, equation number 1. And according to equation number 1, we get that A plus B squared equals to 34 squared. That is to say, A plus B squared equals to 34 squared is 1156. So we found out that A plus B squared equals to 1156. Here we'll open the brackets on this side of the equation number 1, and we'll get that according to equation number 1, A plus B squared equals to A squared plus B squared plus 2 times AB. It is equal to 1156. So according to equation number 1, A squared plus B squared plus 2 times AB equals to 1156. In the next step, we'll focus on the right triangle, triangle ABC. Triangle ABC is a right triangle because of the fact that angle ACB equals to 90 degrees. Okay. So we will implement the Pythagoras theorem on the right triangle, triangle ABC. Here, by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of triangle ABC is AB, so the square of the hypotenuse is AB squared. And it is equal to the sum of the squares of the perpendiculars, that is to say it is equal to AC squared plus BC squared. So we found out that according to equation number 2, AB squared equals to AC squared plus BC squared. According to our definition, AB equals to C, so it is, we substitute AB by C. AB is C, so AB squared is C squared. That is equal to AC squared. Here AC equals to A, so AC squared is A squared plus BC squared. BC equals to B, so BC squared is B squared. So we found out that going to equation number 2, C squared equals to A squared plus B squared. But we have already found out that C, that is the diameter of the big circle, equals to 26 units. So C squared will be equal to 26 squared. That is equal to A squared plus B squared. (26 squared) is 676. So in conclusion, we found out that A squared plus B squared equals to 676. According to question number 2. And because of the fact that A squared plus B squared equals to 676, it means that we can substitute A squared plus B squared in equation number 1 by 676. So we'll do it now, and we get that according to equation number 1, A squared plus B squared is 676. That is equal to A676 plus 2AB. Plus 2AB according to equation number 1 equals to 1156. Here we subtract 676 from this equation number 1, and we find out that 2 times AB equals to 1156 from 676. This is 480. So we found out that according to equation number 1, 2 times AB equals to 480. We divide this equation number 1 by 2, and we get that A times B equals to 480 over 2 is 240. And we divide the equation number 1 by 2, and we get that according to equation number 1, AB over 2 equals to 240 over 2 is 120. Okay? So, what is the area of the blue shape? It is very easy to see from the drawing that the area of the blue shape is equal to the area of triangle ABC minus the area of the small circle. I repeat again. From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So the area of the blue shape equals to the area of triangle ABC. The area of triangle ABC equals to the base of the triangle that is AC times the height to the base that is CB over 2. Minus the area of the small circle that is equal to pi r squared. So the area of the blue shape equals to AC is A according to our definition, BC is B over 2. So the area of triangle ABC equals to A times B over 2 minus the area of the small circle that is pi r squared. R equals to 4 units. If R equals to 4 units, R squared is 16, because it is 4 squared is 16. So 16 times pi is 16 pi. the area of the small circle equals to 16 pi. And the area of triangle ABC equals to AB over 2. But AB over 2, we have only found out that AB over 2 equals to 120. So we substitute AB over 2 by 120. So the area of the blue shape equals to the area of triangle ABC, that is 120, minus the area of the small circle, that is 16 pi. Okay, so in conclusion, the area of the blue shape equals to 120 minus 16 pi, or in terms of numbers, it is equals to 69.73 square units. I'll repeat again, the area of the blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. Okay, so we actually finished the first question. In the next step, I will present to you the second question, and we will solve the second question in 3 different methods. Okay. So in the drawing, we have this circle, and this circle blocks triangle ABC. That is to say, triangle ABC is inscribed by this circle, and the area of triangle ABC, this triangle ABC, equals to 9 square units. Side AB of triangle ABC equals to 5 units. Side BC equals to 6 units. And we want to find out the radius of this circle that blocks triangle ABC. Okay, we'll start with the first method. In the first method, from point A, we'll draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point A and BC as D. We actually know that the area of triangle ABC equals to 9 square units, so we can write down that the area of triangle ABC is equal to 9 units, but the area of any triangle is equal to the base of the triangle times the height to the base over 2. The base of triangle ABC is BC, times the height to the base, that is AD, over 2. Okay, so the area of triangle ABC, that is equal to 9 units, it is equal to the base BC times the height AD over 2. That is to say, 9 equals to BC equals to 6 units. It is given as the question, so it is 6 over 2 times AD. 6 over 2 is 3, so we found out that according to equation number 1, 9 equals to 6 over 2 is 3, so it is 3 times AD. Here we'll divide this equation number 1 by 3, and we'll get that AD, according to equation number 1, AD equals to 9 over 3 is 3. AD equals to 3 units. So we found out here that AD equals to 3 units. In the next step, we will focus on the right triangle ADB. On the right triangle ADB, by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, right triangle ADB. By PT we get that the square of the hypotenuse is AB, so the square of the hypotenuse is AB squared, and it is equal to the sum of the squares of the perpendiculars. That is to say it is equal to AD squared plus BD squared. I repeat again, in the right triangle ADB, according to the Pythagoras theorem, AB squared equals to AD squared plus BD squared. So here, according to equation number 2, we get that AB is 5, so AB squared is 5 squared, that is 25. That is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus BD squared. So according to equation number 2, we found out that 25 equals to 9 plus BD squared. So according to equation number 2, 25 equals to 9 plus BD squared. Here we will subtract 9 from this equation, equation number 2. And you will get that according to equation number 2, 25 minus 9 is 16 equals to BD squared. Here we will take a root from this equation, equation number 2, and we'll get that according to equation number 2, BD equals to the square root of 16, that is 4. So BD equals to 4 units. So we actually found out that here BD equals to 4 units. And what is the length of line segment DC? It is very easy to see from the drawing. That DC equals to BC minus BD. BC minus BD equals to DC. So DC equals to BC equals to 6 units. According to what is given in the question, minus BD, we just right now found out that BD equals to 4. So in conclusion, DC equals to 6 minus 4, that is to say DC equals to 6 minus 4 is 2. DC equals to 2 units, so we can write here that DC equals to 2 units. So in the next step we'll focus on the right triangle, triangle ADC. On the right triangle, triangle ADC, by PT, that is to say by Pythagoras theorem, we'll get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse is AC, therefore the square of the hypotenuse is AC square. That is equal to the sum of the squares of the perpendiculars, that is to say it is equal to AD square plus DC square. I'll repeat again. In the right triangle, triangle ADC according to the Pythagoras theorem, we get that AC square equals to AD square plus DC square. So actually we found out that AC square equals to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DC square. DC equals to 2, so DC square is 2 squared, that is 4. So in conclusion, we found out that AC square equals to 9 plus 4 is 13. AC square equals to 13. Here we take a root out of this equation and we'll find out that AC equals to the square root of 13 units. AC equals to the square root of 13 units, so we can write here that AC equals to the square root of 13 units. In the next step we will define the center of this circle as O, and we will join points O, A and O together by a straight line. And then we will extend AO by a straight line until it touches the circle. And we will define the touching point between the extended line segment AO and the circle as point E. Actually, chord AE is a chord that passes for point O, that is the center of the circle, and any chord in a circle that passes for the center of the circle is defined as the diameter of the circle. So AE that passes for point O, that is the center of this circle, it is the diameter of the circle. So actually, if we define the diameter, if we define the radius of this circle as capital R, then the diameter of the circle will be equal twice as long as the radius. That is to say, the diameter AE will be equal to R, 2 times capital R. Okay, so here in the next step we will join points B and D together by a straight line. Here we have angle ABE. This angle rests on AE, that is the diameter of this circle. And any peripheral angle, angle AB is defined as peripheral angle. Any peripheral angle that rests on the diameter of the circle, it is equal to 90 degrees. So angle BE, that rests on AE, that is the diameter of the circle, equals to 90 degrees. Okay, so angle AB equals to 90 degrees. And we have another rule that states that peripheral angles that rest on the same chord are equal to each other. Peripheral angles that rest on the same chord or on the same chord are equal to each other. So here, if we focus on chord AB, then those two angles, they both rest on chord AB, therefore they must be equal to each other. So that is to say, angle ACB rests on chord AB, it must be equal to angle AEB, that is also rests on the same chord, chord AB. Okay, according to the rule that I mentioned, angle ACB must be equal to angle AB because both of them are rest on chord AB. So if we define angle AEB as theta, here angle AEB equals to theta according to our definition, then from this equation angle ACB equals to angle AEB equals to theta, we will derive that angle ACB is also equals to theta. So angle ACB is also equals to theta. So actually in this triangle ADC, angle ACB equals to theta, angle ADC equals to 90 degrees, so angle DAC must be equal to 90 degrees minus theta in order to complete the sum of the angles in this triangle ADC to 180 degrees. This angle must be equal to 90 degrees minus theta, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees equals to 180 degrees. For the same reason, if we focus on the right triangle ABE, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. Okay? So in the next step, we will prove that the right green triangle ABE, is similar to the right green triangle ADC. Okay, so we prove that the two green right triangles are similar to each other. So triangle ABE and triangle ADC, they are similar to each other. Why they are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So angle ABE equals to this angle that is actually angle ADC, and they are both equal to 90 degrees. I repeat again, angle AB equals to angle ADC equals to 90 degrees. In addition, we have those two angles, they are both equal to theta, therefore they are equal to each other. So angle AEB, this angle, equals to this angle that is actually angle ACD, and they are both equal to theta. I'll repeat again. Angle AB equals to angle ACB, they are both equal to theta. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this angle is actually angle EAB. Equals to this angle, this is actually angle DAC. And they are both equal to 90 degrees minus theta. Therefore they are equal to each other. So we actually found out that all three angles of triangle EAB can go into all three angles of triangle ADC, Therefore, triangle ABE is similar, this is the sign of similar, to triangle ADC according to angle similarity rule. Okay, and from the fact that those two triangles can go into each other, those two triangles are similar to each other, we'll conclude that the following equation is true. We conclude that AB over AD equals to AE over AC. Repeat again. From the fact that the two great triangles are similar to each other, we conclude that AB over AD equals to AE over AC. AB equals to 5 units, AD equals to 3 units, AE is the diameter of this circle that is equal to 2 times capital R, and we already found out that here AC equals to the square root of 13 units. So in conclusion, I found out that according to equation number 2, 5 over 3 equals to 2R times square root of 13 units. Here we will multiply this equation number 2 by square root of 13. And we get that according to equation number 2, 5 times square root of 13 over 3 equals to 2 times capital R. Here we will divide this equation number 2 by 2, and we get that R, the radius that we are looking for, is equal to 5 times square root of 13 over 3, 2 times 3 is 6. Okay? So in conclusion, we found out that the radius of this circle that blocks triangle ABC is equal to either 5 times square root of 13 over 6 units, or in terms of numbers, it is about 3.00 units, that is a little bit greater than 3 units. And the other digits are not 0, so it is a little bit greater than 3 units. Okay? So we finished with the first method. In the next step I will present to you how to find out the radius of this circle according to the second method. In the second method, we'll use all the things that we already found out in the first method. So here, from point A, we draw perpendicular on BC. So this angle equals to 90 degrees. And this angle also equals to 90 degrees. According to our construction, we define the touching point of the perpendicular from point A and BC as D. We already found out in the first method that AD equals to 3 units, DC equals to 2 units, and BD equals to 4 units. So I'll not repeat on it. In the next step, we'll extend 9 segment AD until it touches the circle, and we'll define the touching point of the extended 9 segment AD and the circle as point E. And here, actually, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, so here this angle must be also equal to 90 degrees, and this angle must be also equal to 90 degrees. So all the angles around point D are right angles. Okay. In the next step, I will present to you rule number 1. According to rule number 1, if we have here chord AB, this is chord AB that intersects with chord CD. This is called CD, and the intersection point occurs at point O. Then, according to rule number 1, the following equation is true: that AO times OB equals to CO times OD. Okay. AO times OB equals to CO times OD. We actually can implement rule number 1 in our drawing. Why? Because in our drawing we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AD times DE. And again, according to rule number 1, the implementation of rule number 1 in our drawing is the equation that BD times DC equals to AD times DE. Here BD equals to 4 units DC equals to 2 units, AD equals to 3 units, and DE is the missing line segment, so we leave it as it is. So in conclusion, according to rule number 1, we found out that 4 times 2 is 8 equals to 3 times DE. Here we divide this equation by 3 and we get that DE, the missing line segment DE equals to 8 over 3 units. 8 over 3 units. So here DE equals to 8 over 3 units. In the next step I'll present to you rule number 2. According to rule number 2, if we have this circle, and inside this circle we have called AB. This is called AB. That intersects with called CD. This is called CD. And the two chords intersect with each other at 90 degrees. That is to say, in the intersection point they create 90 degrees between them. Then according to rule number 2, the following, so if here the length of when define the intersection point is point O, so here AO equals to A units in its length, OB equals to B units in its length, CO equals to C units in its length, and OD equals to D units in its length. Then according to rule number 2, 4 times R squared equals to A squared plus B squared plus C squared plus D squared. Okay, I repeat again. According to rule number 2, if chord AB intersects with chord CD at 90 degrees, then the following equation is true that 4 times R squared, R is the radius of the circle, equals to A squared plus B squared plus C squared plus D squared. Actually, we can implement rule number 2 in our drawing, because in our drawing we have chord AE that intersects with chord BC at 90 degrees. All the angles around point D are equal to 90 degrees, therefore, according to rule number 2, we get that 4 times R squared, R is the radius of the circle, equals to BD squared plus DC squared plus AD squared plus DE squared. Okay, so this equation is the implementation of rule number 2 in our drawing. Okay, so here 4R squared equals to BD squared. BD equals to 4, so BD squared is 4 squared, that is 16, plus DC squared. DC equals to 2 units, therefore DC squared is 2 squared, that is 4, plus AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus d squared. D equals to 8 over 3, so d squared is 8 over 3 squared, that is to say it is 64 over 9. So in conclusion, we found out that 4r squared equals to 16 plus 4 is 20, plus 9 is 29. 29 plus 64 over 9. So here we'll multiply 29 by 9 and then we'll divide it by 9 in order to have a common factor with this expression. 29 times 9 is 261 plus 64 over 9. 261 plus 64 is 425 over 9. So in conclusion, we found out that 4 times r squared equals to 325 over 9. Here we'll divide this equation by 4 and we get that r squared equals to 325 over 9 times 4 is 36. 325 is 25 times 13. We substitute 325 by 25 times 13 over 36. Here we will take a root out of this equation and we get that r equals to the square root of 25 is 5 over square root of 36 is 6 times square root of 13. So we found out that r equals to 5 over 6 times square root of 13 units. So in terms of numbers it is equal to 3.00 units. That is a little bit greater than 3 units. We finished with the second method. In the next step I will present to you how to find out the radius of this circle that blocks triangle ABC according to the third method. Okay. In the third method, we define angle ABC as theta, and we actually have a new formula to find out the area of any triangle. Actually, I've already mentioned this rule or this formula. I showed it you in the past, so I'll do it quickly. If this is triangle ABC, that could be any triangle, and we know that the length of side AB is A units and side AC equals to B units in its length. The angle between side AB and side AC is theta. Then the area of this triangle, triangle ABC, according to the special formula, it will be equal to A times B times sinus theta over 2. We'll use this formula in order to calculate the area of our triangle, triangle ABC. Although we know that the area of the triangle is equal to 9 square units, we use the formula in order to find out the value of sinus theta. Okay, so the area of this triangle according to the new formula will be equal to 5 times 6 times sinus theta over 2. But we know that the area of this triangle equals to 9 square units, so the only missing variable is sinus theta. So by solving this equation we find out the value of sinus theta. So the area of the triangle is 9 square units and it is equal to 5 times 6 times sinus theta over 2. Here 5 times 6 is 30 and 30 over 2 is 15. So 9 equals to 15 times sinus theta. Here we divide this equation by equation number 1 by 3. So 9 over 3 is 3. 15 over 3 is 5. So we found out that according to equation number 1, 3 equals to 5 times sinus theta. Here we'll divide this equation by 5. And we'll get that according to equation number 1, sinus theta equals to 3/5. Sinus theta equals to 3/5. Actually, we have the trigonometric identity that states that sinus theta, actually cosine theta equals to the square root of 1 minus sinus square theta. So cosine theta equals to the square root of 1 minus, here sinus theta equals to 3/5. Therefore sinus square theta will be equal to 3/5 squared. 3/5 squared is 3 squared, that is 9, over 5 squared, that is 25. So here we find out that cosine theta equals to the square root of 1 minus 9 over 25. Here we multiply 1 by 25 and we'll divide it by 25 in order to account factor with this expression. So we will get that cosine theta equals to 25 minus 9 over 25. That is to say, cosine theta equals to the square root of 25 minus 9 is 16 over 25. So we actually found out that cosine theta equals to the square root of 16, that is 4, over square root of 25, that is 5. So in conclusion, we found out that cosine theta equals to 4/5. Cosine theta equals to 4/5. In the next step, we will implement the law of cosines in our triangle ABC. So I will remind you what is the law of cosines quickly. The law of cosines is true in any triangle. So if we have triangle ABC that could be any triangle, this is triangle ABC. The angle between side AB and side AC is theta. Side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. Then, according to the law of cosines, we'll get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Okay? We'll implement the law of cosines in our triangle ABC. In our triangle ABC, the implementation of the law of cosines means that if cosine theta will be equals to 5 squared, that is 25, plus 6 squared, that is 36, minus AC squared over 2 times 5 times 6. Okay? So here, according to equation number 2, cosine theta, we already found out that cosine theta equals to 4/5. So we substitute cosine theta by 4/5. And it is equal to 25 plus 36 is 61, minus AC squared over 5 times 6 is 30, and 30 times 2 is 60, Here we'll multiply this equation by 16. By 16 we get that according to equation number 2, 60 times 4 over 5 equals to 61 minus AC squared. Here 60 over 5 is 12. So it is 12 times 4 equals to 61 minus AC squared. 12 times 4 is 48. So I found out that 48 equals to 61 minus AC squared. Here we'll add to this equation number 2 AC squared, and we will subtract 48 simultaneously, and we get that according to equation number 2, AC squared equals to 61 minus 48 is 13. So AC squared equals to 13. Here we take a root out of this equation number 2, and we get that AC equals to the square root of 13 units. AC equals to the square root of 13 units. So we can write here in the drawing that AC equals to the square root of 13 units. In the next step I will present to you a new formula for the radius of a circle that blocks triangle like in our drawing. The radius of any circle that blocks a triangle will be equal to the multiplication of the sides of the triangle by each other. In this case is AB times AC times BC. AB times AC times BC over 4 times the area of the triangle that is blocked by the circle. The area of the triangle that is inscribed by the circle is triangle ABC. Okay, so the radius of this circle that blocks triangle ABC will be equal to the multiplication of the sides of the triangle by each other over 4 times the area of this triangle that is described by the circle. Okay, so we get that R equals to AB is 5 times AC is square root of 13 times BC is 6 over 4 times the area of triangle ABC. And it is given as the equation that the area of triangle ABC equals to 9 square units. So in conclusion, found out that the radius of the circle that blocks triangle ABC equals to 5 times 6 is 30. So it's 30 times square root of 13 over 4 times 9 is 36. Here we divide both the numerator and the denominator of this side of the equation by 6. And we get that R equals to 30 over 6 is 5 times square root of 13 over 36 over 6 is 6. So we found out in conclusion that the radius of the circle that blocks triangle ABC equals to either 5 times square root of 13 over 6 units, or in terms of numbers it is about 3.00 units. That is a little bit greater than 3 units. Okay, we finished with the third method. In the next step I will summarize the lecture. We'll start of course with the first question. In the drawing we have a circle. Triangle ABC is inscribed by the big circle. Inside this circle we have the triangle ABC, but triangle ABC blocks also the small circle. That is to say, the small circle is described by triangle ABC. We know that AB is the diameter of the big circle. The radius of the big circle equals to 13 units, while the radius of the small circle equals to 4 units. And we want to find out the blue area. Okay. So first of all, we defined the center of this circle as point O. We define the point of tendency of tangent BC with this circle as M. We define the point of tendency of tangent AC with this small circle as N. And we define the point of tendency of tangent AB with this circle as L. Then we join points O and N together by a straight line. O is the center of the small circle. N is a point on the small circle itself. This is exactly the definition of a radius. So ON is the radius of the small circle that is equal to 4 units according to what is given as the question. And we have rule number 1 that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. So according to rule number 1, whenever we have the radius that is drawn to the point of tendency, like in this drawing, we have the radius ON that is drawn to the point of tendency. And because of the fact that the radius ON is drawn to the point of tendency, then according to rule number 1, the tangent AC will be perpendicular to the radius NO. So AC is perpendicular to NO, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Likewise, we joined points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle, small circle itself, therefore it is the radius. The radius of the small circle OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency B in this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? And we also have rule number 2 that says that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So peripheral angle ACB, this angle ACB rests on AB, that is the diameter of the big circle, therefore it is equal to 90 degrees. That is to say this angle ACB equals to 90 degrees. So in quadrilateral ONCM we have 1, 2, 3 right angles. Okay, in quadrilateral ONCM we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actual angle MON. In total, the sum of the 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation. We found out that the missing angle MON, this angle equals to 360 degrees, minus 90 degrees, it is 90 degrees. So this angle, it is a right angle. So actually found out that in quadrilateral ONCM we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral ONCM as a rectangle. But we know that the opposite sides of a rectangle are equal to each other. So in rectangle OMCM, ON must be equal to CM. ON must be equal to CM according to the rule that the opposite sides of a rectangle are equal to each other. But here ON equals to 4 units. It is the radius of the circle. So we can write down that ON equals to 4. And from this equation 4 equals to ON equals to CM, we will derive that CM is also equal to 4 units. Okay, here cm is also equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that OM equals to NC. OM equals to NC, but we have already found out that OM equals to 4 units. It is the radius of the circle. OM equals to 4 units, and from this equation 4 equals to OM equals to NC, we derive that NC is also equals to 4 units. Here NC equals to 4 units, so we actually found out that quadrilateral OMCN, it is not a rectangle but a square. Okay, then we defined AN, we defined here AC SA, here AC equals to A, side AC of triangle ABC equals to A according to our definition, side CB of triangle ABC equals to B according to our definition, and side AB of triangle ABC equals to C according to our definition. And then, what is the length of side line segment AN? It is very easy to see from the drawing that AN equals to AC minus NC. Again, AC minus NC equals to AN. AN equals to AC minus NC. So AN equals to AC. AC equals to A according to our definition. NC equals to 4 according to what we have already found out. So in conclusion, we found out that AN equals to A minus 4. Here AN equals to A minus 4. Likewise, we found out the length of line segment MB. What is the length of line segment MB? It is very easy to see that MB equals to CB minus CM. Again, CB minus CM equals to MB. MB equals to CB minus CM. So MB equals to CB, CB equals to B according to our definition, and here CM equals to 4 units according to what we already found out. So in conclusion, we found out that MB equals to B minus 4. Here MB equals to B minus 4. So in conclusion, we found out that MB equals to B minus 4 and AN equals to A minus 4. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Again, the lengths of two tangents from a common external point to a circle are equal. So if we focus on the common external point, point A, from point A we have two tangents to the circle, tangent AL and tangent AN, and they are equal to each other according to rule number 2. At point A, the common external point, point A, AL equals to AN according to rule number 2. But here we already found out that AN equals to A minus 4, so we can write here that AN equals to A minus 4, and from this equation AL equals to AN equals to A minus 4, we'll derive that AN is also equals to A minus 4. Here AL is also equals to A minus 4. Okay, likewise, then we focused on the common external point, point B. From the common external point, point B, we have two tangents to the small circle, tangent BL and tangent BM. And according to rule number 2, they must be equal to each other. At point B, BL equals to BM, according to rule number, actually 2 or 3, is the rule that the length of two tangents from a common external point to a circle are equal. Okay? So BL equals to BM, according to the rule that I mentioned. But here we have already found out that BM equals to B minus 4. So BM equals to B minus 4, according to what we already found out. So from this equation, BL equals to BM equals to B minus 4, we derive that BL is also equals to B minus 4. Here, BL is also equals to B minus 4. So in conclusion, we found out that LB equals to B minus 4 and AL equals to A minus 4. Okay? We know that AB is the diameter of the big circle according to what is given as the question. From the drawing it is very easy to see that AB equals to AL plus LB. Okay? AB equals to AL plus LB. That is to say AB equals to AL, that is A minus 4, plus LB, that is B minus 4. So in conclusion, we found out that AB equals to A minus 4 plus B minus 4. That is to say AB equals to A plus B. Minus 4 is minus 8. So AB equals to A plus B minus 8. But AB itself equals to, that is the diameter, it is twice as long as the radius, and the radius of this circle, the big circle, equals to 13 units. Therefore, the diameter must be equal twice of, it is twice as long as the radius, that is to say it is equal to 14 times 2, that is 26 units. Here, the diameter AB equals to 26 units, and we have already found out that the diameter AB that is equal to 26 units, it is equal to A plus B minus 8. Here we added 8 to this equation and found out that according to equation number 1, 26 plus 8 is 34, so 34 equals to A plus B according to equation number 1. We squared this equation number 1, and we got that A plus B squared equals to 34 squared. 34 squared is 1156. So in conclusion, we found out that according to equation number 1, A plus B squared equals to 1156. We open the brackets on this side of equation number 1 and found out that A plus B squared equals to A squared plus B squared plus 2 times AB. Then we focus on the right triangle, triangle ABC. Triangle ABC is the right triangle because of the fact that angle ACB equals to 90 degrees. According to the Pythagoras theorem, on the right triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is AB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AC squared plus BC squared. I repeat again, according to the Pythagoras theorem, in the right triangle ABC, AB squared must be equal to AC squared plus BC squared. But AB equals to C according to our definition, AC equals to A according to our definition, and CB equals to B according to our definition. That is to say, we found out that C squared equals to A squared plus B squared. C is 26, so C squared is 26 squared. So according to equation number 2, we found out that 26 squared equals to A squared plus B squared. So according to equation number 2, A squared plus B squared equals to 26 squared, that is 676. So according to equation number 2, A squared plus B squared equals to 676. So we can substitute A squared plus B squared in equation number 1 by 676 according to equation number 2. We did it and we got that here in equation number 1, A squared plus B squared is 676 plus 2AB equals to 1156. We subtracted 676 from this equation number 1, and found out that 2 times AB equals to 1156 minus 676 is 480. So we found out that 2 times AB equals to 480. We divided the equation number 1 by 2 and we got that 2 times AB over 2 is AB. AB equals to 480 over 2, that is 240. So according to equation number 1, we found out that AB equals to 240. We divided the equation number 1 by 2 and we found out that AB over 2, according to equation number 1, AB over 2 equals to 120. AB over 2 equals to 120. And what is the area of the blue shape? From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. The area of the blue shape equals to the area of triangle ABC minus the area of the small circle. the area of triangle ABC equals to the base of the triangle that is AC times the height to the base that is CB over 2. The area of triangle ABC equals to AC times BC over 2. The area of the small circle equals to pi r square when r equals to 4 units. So the area of the blue shape equals to AC is A, BC is B. So A times C, AC times BC over 2 is AB over 2. So the area of triangle ABC is AB over 2 minus the area of the circle is pi r equals to 4, so r squared is 4 squared, that is 16. So in conclusion, the area of the small circle is 16 pi. AB over 2 is 120, so we substitute AB over 2 by 120. We found out in conclusion that the area of the blue shape equals to 120 minus 16 pi square units. So in terms of numbers, it is equal to 69.73 square units. Okay, so the area of this blue shape equals to either 120 minus 16 pi square units. So in terms of numbers, it is equal to 69.73 square units. We finished with the first question. Then I presented to you 3 different methods to find out the radius of the circle that blocks triangle ABC. In the drawing we have this circle. This circle blocks triangle ABC, or triangle ABC is inscribed by this circle. We know that the area of triangle ABC is equal to 9 square units. Side AB equals to 5 units, side BC equals to 6 units, and we want to find out the area of this circle that blocks triangle ABC. Okay. So first of all, from point A, we draw perpendicular on BC, so this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our definition, according to our construction, of course. Then we define the touching point of the perpendicular from point A and BC is D, and we know that the area of triangle ABC equals to 9 square units, and the area of triangle ABC equals to 9 square units, but the area of any triangle is the base of the triangle that is BC times the height to the base that is AD over 2. BC equals to 6 units, AD is the height over 2. So 9 equals to 6 over 2 is 3. So according to equation number 1, 9 equals to 3 times AD. We divided equation number 1 by 3 and we found out that AD equals to 3 units. So here AD equals to 3 units. Then we focus on the right triangle ADB. On the right triangle ADB. According to the Pythagoras theorem, AB square equals to AD square plus DB square. AB square equals to AD square plus DB square. AB is 5, so AB square is 5 square, that is 25. That is equal to AD square. AD is 3, so AD square is 3 square, that is 9, plus DB square. We subtracted 9 from this equation number 2, and we found out that 25 minus 9 is 16. So 16 equals to BD square. We took out of this equation number 2, and we found out that BD equals to the square root of 16. That is 4. So if BD equals to 4 units. And what is the length of DC? From the drawing it is very easy to see that DC equals to BC minus BD. DC equals to BC minus BD. That is to say DC equals to BC, that is 6, minus BD, that is 4. That is to say DC equals to 6 minus 4, that is 2. So here DC equals to 2 units. Then we focus on the right triangle ADC. According to the Pythagoras theorem, AC square equals to AD square plus DC square. On the right triangle ADC, AC square equals to AD square plus DC square. That is to say AC square equals to AD square. AD is 3, so AD square is 3 square, that is 9, plus DC square. DC is 2, so DC square is 2 square, that is 4. So in conclusion, we found out that AC squared equals to 9 plus 4, that is 15. We took out 9 plus 4, that is 13. So AC squared equals to 13 units. We took out of this equation and we found out that AC equals to the square root of 13 units. Here AC equals to the square root of 13 units. Then from point, we define the center of the circle as point O, and from point, we join points A and O together by a straight line. Then we extended right segment OA by a straight line until it touches the circle at point E. Point E is the touching point of the extended AO and the circle. Okay, so line segment or chord AE passes through the center of this circle, that is point O. Therefore, chord AE is the diameter of the circle, because any chord that passes through the center of the circle is defined as the diameter. So AE is the diameter of this circle. Then we join points E and B together by a straight line. We created angle ABE. Angle ABE rests on AE, that is the diameter of the circle, and any peripheral angle that rests on the diameter of a circle equals to 90 degrees. That is to say, peripheral angle ABE that rests on the diameter of the circle must be equal to 90 degrees. So ABE equals to 90 degrees. Then we have also the rule that peripheral angles that rest on the same chord are equal to each other. Here, those two angles, they are both rest on chord AB, therefore they are equal to each other. Here, angle ACB equals to angle AB, according to the rule that peripheral angles that rest on the same chord are equal to each other. They both rest on chord AB, therefore they are equal to each other. Then we define angle AEB as theta. So here angle AB equals to theta according to our definition. So from this equation, angle ACB equals to angle AB equals to theta, we derive that angle ACB is also equals to theta. Here this angle ACB is also equals to theta. Then we proved that those two right green triangles are similar to each other. Why they are similar to each other? Because first of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. Those two angles are both equal to theta, therefore they are equal to each other. Those two angles, they are both equal to 90 degrees from theta, therefore they are equal to each other. So all the angles of triangle AB can go into all the angles of triangle ADC. Therefore we prove that triangle AB is similar to triangle ADC according to angle similarity rule. And from the fact that the two triangles are similar to each other, we conclude that AB over AD equals to AE over AC again. AB over AD equals to AE over AC. AB equals to 5, AD equals to 3. AE is the diameter of the circle, that is 2r. AC equals to square root of 13 units. We multiplied this equation number 2 by square root of 13 units, and we found out that 2r equals to 5 times square root of 13 over 3. We divided the equation number 2 by 2 and found out that the radius of the circle that we are looking for, it is equal to either 5 times square root of 13 over 6 square units, or in terms of numbers, it is a little bit greater than 3 units. We finished actually in the first method. Then I presented to you how to find out the radius of the circle according to the second method. In the second method, we use the same thing that we already found out in the first method. Here, from point A, we do perpendicular on BC. We define the touching point as D. AD equals to 3 units according to the first method. DC equals to 2 units according to the first method. BD equals to 4 units according to the first method. Then we extended side AD by a straight line until it touches the circle at point E. Point E is the touching point of the extended AD and the circle. Then I presented to you rule number 1. We implemented rule number 1 in our drawing. What is rule number 1? According to rule number 1, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We implemented rule number 1 in our drawing. In our drawing, we know that chord AE intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AD times DE. According to rule number 1, we get that BD times DC equals to AD times DE. BD equals to 4, DC equals to 2, AD equals to 3, and DE is the missing line segment. 4 times 2 is 8, so 8 equals to 3 times DE. We divided this equation by 3 and found out that DE, the missing line segment, equals to 8 over 3 units. Okay? Here, DE equals to 8 over 3 units. Then I presented to you rule number 2, and we implemented rule number 2 in our drawing. What is rule number 2? Rule number 2 states that if chord AB intersects with chord CD at 90 degrees, that is to say, they create 90 degrees in the intersection points. So if this is the case, then the following equation is true. The 4R square equals to A square plus B square plus C square plus D square. Here A, B, C, and D are the lengths of AO, OB, OD, and CO. Okay? Again, 4 times R square equals to A square plus B square plus C square plus D square. In our drawing, we have chord AE that intersects with chord BC at 90 degrees. All the angles on D are equal to 90 degrees, therefore we can implement rule number 2 in our drawing. According to rule number 4, we get to rule number 2, we will get that 4 times A square, 4 times R square, R is the radius of the circle, equals the radius of the circle that blocks the chords. It is equals to BD square plus DC square plus AD square plus DE square. Again, 4 times R square equals to BD square plus DC square plus AD square plus DE square. Here, 4 times R square equals to BD square plus DC square plus AD square plus DE square, according to rule number 2, of course. So 4 times R square equals to BD square. BD equals to 4, so BD square is 4 squared, that is 16. Plus DC square. DC is 2, so DC square is 2 squared, that is 4. Plus AD square. AD is 3, so AD square is 3 squared, that is 9. Plus DE square. DE is 8 over 3, so DE square is 8 over 3 squared, that is 64 over 9. 16 plus 4 is 20, and 20 plus 9 is 29. And so we have 29 plus 64 over 9. So we multiply 29 by 9, and then we divide it by 9 in order to overcome factor of this expression. And we found out that 29 times 9 is 261 plus 64 over 9 equals to 4R squared. 261 plus 64 is 325 over 9. So in conclusion, we found out that 4 times R squared equals to 325 over 9. We divided this equation by 4 and we found out that R squared equals to 325 over 4 times 9 is 36. We substituted 325 by 25 times 11 times 13. 25 times 13 equals to 325. Then we took a root out of this equation and found out that the radius of the circle that blocks triangle ABC equals to either the square root of 25 is 5 and the square root of 36 is 6. So the radius of the circle that blocks triangle ABC equals to either 5 times square root of 13 over 6 units, so in terms of numbers it is a little bit greater than 3 units. We finished with the second method, then I presented to you how to find out the radius of this circle that blocks triangle ABC according to the third method. We define the angle ABC as theta, and here we have a special formula to find out the area of any triangle. If this is triangle ABC, that could be any triangle. The angle between side AB and side AC is theta. Side AB equals to A unit, side AC equals to B units in its length. Then the area of this triangle, triangle ABC, will be equal to A times B times sinus theta over 2. We implemented this rule in order to find out the area of our triangle, triangle ABC. According to this formula, the area of this triangle, triangle ABC, will be equal to 5 times 6 times sinus theta over 2. The area of this triangle equals to 5 times 6 times sinus theta over 2, but we already know, that the area of this triangle equals to 9 units. It is given as the question. So according to equation number 1, we get that 9 equals to 5 times 6 times sinus theta over 2. 5 times 6 is 30, and 30 over 2 is 15. So in conclusion, we found out that 9 equals to 15 times sinus theta. We divided this equation number 1 by 3, and we got that 9 over 3 is 3, and 15 over 3 is 5. So in conclusion, we found out that 3 equals to 5 times sinus theta. We divided this equation by 5, and we found out that sinus theta equals to 3/5. We have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. So here, if sinus theta equals to 3/5, then sinus square theta will be equal to 3/5 squared, that is 9 over 25. Then we multiplied 1 by 25, we divided by 25 in order to have a common factor with this expression. We found out that 25 minus 9 over 25, the square of it equals to cosine theta. 25 minus 9 is 16, so it is 16 over 25. The square root of 16 is 4, the square root of 25 is 5. So in conclusion, we found out that cosine theta equals to 4/5. Then we implemented the law of cosines in this triangle ABC. What is the law of cosines? The law of cosines is true in any triangle. So if we have this triangle ABC, that could be any triangle. The length of AB is A, the length of AC is B, and the length of BC is C, and the angle between side AB and side AC is theta. Then cosine theta equals to A square plus B square minus C square over 2 times AB. We implemented the law of cosines in this triangle ABC. According to the law of cosines, we get that cosine theta equals to 5 squared, that is 25, plus 6 squared, that is 36, minus AC squared over 2 times 5 times 6. We have already found out that cosine theta equals to 4/5. So 4/5 equals to 25 plus 36 is 61, minus AC squared over 5 times 6 is 30, and 30 times 2 is 60. We multiplied the equation number 2 by 60, and we found out that 60 times 4 over 5 equals to 61 minus AC squared. 60 over 5 is 12. So here we have 12 times 4 equals to 61 minus AC squared. 12 times 4 is 48. So 48 equals to 61 minus AC squared. We added AC squared and also subtracted some density 48 from this equation number 2. And we found out that AC squared equals to 61 minus 48 is 13. So AC squared equals to 13. We took out of this equation number 2, and we found out that AC equals to the square root of 13 units. Here AC equals to the square root of 13 units. Then we used the special formula for a circle that blocks triangle. The radius of a circle that blocks triangle will be equal, according to the new formula, to the multiplication of the size of the triangle that is blocked by circle over 4 times the area of the triangle that is blocked by the circle. So here the multiplication of the sides of triangle ABC is AB times AC times BC over 4 times the area of this triangle ABC. AB is 5, AC is square root of 13, and BC is 6. Over 4 times the area of triangle ABC. It is given as the question that the area of triangle ABC equals to 9 units, 9 square units. So it is 4 times 9. So here r equals to 5 times 6 is 30, so here we have 30 times square root of 13, and 4 times 9 is 36. So r equals to 30 over 36 times square root of 13. We divided both the numerator and the denominator of this on the side of the equation by 6, and here 30 over 6 is 5, and 36 over 6 is 6. So in conclusion, we found out that the radius of this circle that blocks triangle ABC equals to either 5 times square root of 13 over 6 units, or in terms of numbers, it is a little bit greater than 3 units. I repeat again, the area of this circle, the radius of this circle that blocks triangle ABC equals to either 5 times square root of 13 over 6 units, or in terms of numbers, the radius of this circle, it is a little bit greater than 3 units. Okay? Thank you very much.